Hello and welcome. Today on the bench we have an interesting piece of test equipment, at least interesting to me. I hope it is with you. In here. Now this is a Triplett model 630 and this is a Triplett model 631. The difference being this is a VOM. This is a VOM and a VTVM. This actually has a vacuum tube inside and operates as a VTVM when this switch is put over into the VTVM range. It came almost complete. Had test leads. This is just a battery clip. And this has nothing to do with it. Came with the case. It came with the manual, the owner's manual. I think it's hidden in the back here. I played with this a little bit. Yep, came with the original instruction manual. The only thing it doesn't have with it is the original VTVM leads. These are the VOM leads. The VTVM leads have a 1 megohm resistor in them, like most VTVMs do on DC voltage. It only does DC voltage on the VTVM. Went online looking for an original. There weren't any originals, but there's a guy online, Mike Kent, I think it is. I'll have to take a look at the business card here. Kent Craft LLC, Mike Kent. And he has an eBay store. VTVM and probe kits, custom test leads, etc. And he makes a setup specifically for this meter. Has the 1 megohm resistor in it, the shielded leads, and everything's terminated in this little block, and it plugs into the VTVM connections. So being an optimist, I bought that. Now I broke my own rule when I bought this, and I'm paying the consequences. I had the guy open it up and show me the inside looking for battery damage. Now it did have, oh gosh, hang on. Once again, I'm fully prepared, as you can tell. I dash off here in the other room. Oh, what the heck, here we go. Inside it did have a D-cell, long dead, but it hadn't leaked. And it had the two 22.5 volt batteries. Of course, these are long dead also, but nothing had leaked. So I lucked out in that regard. What I didn't ask him to do was measure something, you know, like a 1 volt battery, put the leads in and check it. It got here, and sure enough, somebody's blown the thing up. The meter movement is blown out of it. And there's a resistor inside that's cooked. However, it's not the end of the world. Several years ago, I bought a whole lot of these from ESS, I think it was. I think that's where I bought them. For short money, I got a whole lot of them that had broken cases like this. Different bits and pieces broken. Some of the backs were broken, some the front case was broken. I was able to mix and match parts, and I put together 1, 2, 3, I think I put together 5 or 6 good ones. I gave one away. This one's been out in the garage. It works fine. It's just got a big hole blown in the side of the case, and it was my shop radio out in the garage. A shop meter rather, out in the garage. Got radio in the brain. The good news is, well, let me get some of this opened up and show you. Okay, there is one small chip in this case, but other than that, it's in pretty good shape. This is where the two 22.5 volt batteries go in, and that little metal clip is just designed to snap over the top here and hold them in place. I have found that I can put 6 9-volt batteries in here, standing up. Instead of being 22.5 per side, it'll be 27 per side. I don't think that's going to be a problem. It'll make the 100 R times 100K range read a little high until you wheel it back down with the adjustment in the front, but that's not a problem either. There's our tube. It's a 1R5. There's supposed to be back-to-back diodes here, and whoever blew it up stuck a resistor in here. I don't know what they were thinking. This resistor's blown out of it. There's a big skid mark in here. This is a meter rectifier. This is for AC measurements now. These appear to be gone, these 2 resistors, but this rectifier assembly is the same part number that's inside of this unit. This unit has the same exact part number on the back of the switch. The meter movement, both meter movements are identical. They are 50 microampere, 250 millivolt full scale, both of them. Now the part number in the manuals is different because it reflects the dial face, the scale. But the movements themselves are identical. So I can take the movement from that, transplant it into this, and the only thing holding the scale on is 2 small screws. So I'll just swap the scale over to that meter movement and install it in this unit. I may find the right resistor I need in that as well. That'll just become a parts unit. What else? Let's see. I'll have to change the capacitor waxy cap out here. But I think I can save this meter. I think I can resurrect it, if you will. I've always wanted one of these ever since I found out they existed. There's not a lot of them out there. There's a few. You see them online every once in a while getting, ludicrous prices for them. And I overpaid for this one, sadly, because it's dead. If this had been working, I would have had a good deal, but it's obviously had fingers in here. But I'm sure we can recover. This is a very different switch assembly from what's normally in a 630. This has an open frame switch. The 630s all have an enclosed, like a barrel in here. Everything's protected inside it, so this is a bit different. But it looks to be in good shape. I don't see a lot of stuff that's been touched. There's a resistor hanging out the side here. I don't know what they were thinking doing this. That's supposed to be back-to-back diodes for protection. These are the same part number. Just about, everything I'm going to need is the same part number. Fortunately, everything's listed in the book, and it has the parts list, and I have the parts list for both of them. Let's see. Instruments rectifies, 50 microamp, 250 millivolt full scale with panel, and it gives you the part number. The other one is a 50 microampere 250. It gives a different part number, but the panel is different. And let's see here. I'm trying to resist rectifier assembly. It's the same part number, 2250-13N. And both of these have exactly the same part number for that rectifier for the meter. So I should be okay. I should be able to recover from this. Give it a good cleaning. The front of the case is in good shape. And when I get done, I should have a working VTVM that I can walk around with. This last time this had a calibration was 77. Rockford Institute Laboratory. 9977. But again, sadly it was blown up. This is kind of yellowed. This one's in pretty good shape, but except for one little scratch there. I'll try buffing this one up and see how it cleans up. Trouble with cleaning these is you take the anti-static coating off of them. And in fact, when I brought this one over and set it on the bench, see how the needle stays up? You have to wipe them down with like a dryer sheet, and it puts an anti-static coating on them, at least for a while. So let me dig into this. I don't know how this meter movement comes out of here. I know there's 4 nuts back here that allow me access to remove this piece, the window, but I don't know how the meter movement comes out. There's 2 nuts here, but somehow the wiring has to be getting to the meter movement. Since this one's dead already, this will be this will be the first one I pull apart, because I can't do any harm to the meter movement. And I'll find out if this has to be unsoldered first. I don't know how they assemble these, but we're going to find out. We're going to dig into this and find out. So I'll have to take the 1R5 out of here and get to the nut that's hiding. Oh no, I guess I can just about get to it in there without removing it. Okay, I can get to the nut that's in there, and I can get to that one. I'm probably going to have to make a special nut driver to get in there. Extremely thin wall. I'll cut down a sacrificial socket so I can get these nuts in and out of here. And let me get some tools gathered up. As I take this apart, it's obvious that somebody's been into the meter itself at some point. None of these were tight. I was able to just spin them right out. 3 of the nuts were brass. This one's steel, and it's a different thickness than the other 3. So once again, somebody's had their fingers in it. There's the 4 washers. Keep those little fiber washers. And I probably won't be able to see anything, but there we go. I need a little jar to put all the goodies in. I usually have them sitting here. This will do for now. A little tuna fish can. Just to keep everything in one place. Okay. Now I gotta remove. Yeah, the needle's even bent. I wonder if it's actually blown or if the needle's just bent. Alrighty. Now that the needle's moving freely, maybe I should try. Wouldn't that be nice if the meter movement was okay? Let me get a battery and a couple of test leads and see if the needle's alive. I'm pretty sure the meter movement is blown, but before I tear it all apart, let's try it. I got myself a Duraleak D-cell here. And DC milliamperes, DC volts, 3 volt scale. Let's see what happens. No reaction whatsoever. Alright. Ohms. I don't know what range this thing was in when it got blown up. It's hard to say. 1, 1.5. Okay, let's try the ohms range here. We'll put this guy in. Put this on the lowest ohms range. What's interesting, there's no off on this. Yeah, no movement at all of the meter. And let's see, milliamperes, 1200 milliamps. Nope, nothing. And the one last thing I can try is putting a couple of test leads directly on the meter movement. And I know one goes here. And the other one goes to the frame of that trimmer pot. And that's down here. Now you never put a battery directly across a 50 microamp movement. It will die instantly. But what I do to test these is I hold this in my hand, wet my finger. Yeah, that movement's dead. Absolutely nothing. If that movement was any good, it'd go about a quarter scale using my wet finger as a resistor. And yeah, there's no move, nothing. Absolutely dead. So we'll keep digging into this. Let me get my jeweler's screwdrivers over here. And just one last test before I do that. I bypassed that big trimmer cap on the back in case that happens to be blown. Of course, if that's blown, guaranteed the meter movement is. But, let's see. Yeah, absolutely nothing. That's directly across the meter wires. So, all right. Time to dig deeper. All right, let's see what we got ourselves into here. Again, I have no idea how this movement is installed, and that's why I'm taking apart the dead one first, because I can't do any more damage to it than already has been done, as long as I treat this carefully. He says as he drops it face down. Alright, there's another resistor in there. I still don't see how the wiring is tied in. I see wires. Looks like there's plenty of lead length here for me to just lift the meter movement out carefully. Look at this. You can tell somebody's been in here. This wire is pinched underneath the faceplate. The insulation, it's all flattened out. You can tell they were in here and didn't put it back together carefully. Oh goodness. Alright. Well, let me get these two nuts on the back loosened up. I found a pair of needle nose pliers that fit down in the wells. And, okay, that's loose. And that's loose. Stay away from the needle here. Let's see if I can spin these out. I don't know why I'm worrying about the needle. Probably good practice for when I do the good movement. That nut's off. Triplett, I think is now owned by Joule Electric, and they're right over here on the Manchester airport. They have a little factory where they make instrumentation. I don't know if they're still making meters over there. Oh yeah, plenty long. The wires are nice and long. So this shouldn't be too bad. Oh, I think I see a skid mark on the back of the meter coil here. Let's see. Let me set that back in there for a minute. Get my soldering iron warmed up. That's good. That makes it easy to swap out. I can just take the 2 wires off and drop the other meter movement in when I get it out of this meter. Soldering iron. Feels strange to be over this bench. I haven't worked over here in a while. Get my sponge good and wet. Got all my soldering iron over here. Yeah, the field of view on this camera just isn't as good as the old one. Try to get as much of this in view as I can. In fact, I could probably lift the wire right off the meter itself here. But since that wire got crushed, maybe I should replace it. That's interesting. Okay, that comes from the trimmer. There's another, that's in parallel, yeah, that resistor is across the 2 meter terminals. 1 meter terminal comes in here on that post and goes directly to the top of the movement. The one from the bottom of the movement goes to this intermediate post through a resistor to this post, which doesn't appear to be doing any. Oh no, that, okay, from the other post I see there's another wire down there that goes down to this trimmer. So there's a resistor inside of here in series with the movement. But again, that is supposed to be back-to-back diodes, meter protection. Probably blew them right out of there. Alright, let me... okay, that goes to the bottom, that goes to the top. Let me get this out of here. There's that one. That's a big Clive move there. Come on, come on. Okay. That's the bottom one. Let me get a loop and see if I can see anything on that movement. Well, I don't see any smoking gun, but it sure looks like the coil is discolored, like it's been overheated. It's not the normal light brownish coppery color. It's quite dark brown, but the windings in there are so fine that it's really hard to say. But now that I know what I'm up against, I'm going to duplicate what I just did here. I'm going to take the meter movement out of that other unit and put it in here. I'll take this resistor out of here and replace it with the back-to-back diodes that are inside of that meter. For all the good they did this one. I guess it, you know, under mild overload conditions it'll prevent the bent needle. But why he thought a resistor went back there, I have no idea. It does not belong there. Okay, I won't bore you with a second disassembly. It's just going to be more of the same. I will turn the camera back on when I've got something interesting. I just ran out to the garage a few minutes ago to get one of my headlight polishing kits, and I'm looking all around, and then the light dawned. Last trip over to Thailand, I took all of my headlight polishing kits over to Thailand with me because our truck over there, little Toyota, 27 years old, I guess, at this point. The headlights were virtually opaque. And worked those over, and boy, they looked brand new when I got done. And so I used a little Noxon metal polish and turtle wax. And that looks pretty good. I think that'll pass with a push. So we've got our meter cover, and the other one is fairly clear, but it's got one good divot in the front of it, and I'd have to sand that down halfway through the material to get it out. So this one's got one little light scratch. When I get another headlight kit, I'll be able to buff that scratch out of there. That little truck over there, it amazes me. Of course, they don't have snow and they don't have salt, but I climbed underneath that to do a couple of checks. And, there's less rust on that truck than there is after one winter here in New England. It's just incredible. The thing is spotless underneath. There's a light surface haze, you know, on the bare metal underneath there, where it's, you know, just oxidation from being in the air. It is so rust free. And of course, being an old Toyota, it runs like a Swiss watch. But yeah, the headlight kit just changed the whole character of the truck. It looked new when I got done with it. Even the paint's original. And that's amazing for being in the sun over there all the time. Okay, I am going to go ahead, pull the other meter movement out, get it swapped, and we'll come back when that's done. Here's a hint for anybody who attempts this after watching this video. These two screws that hold the meter plate face, whatever you want to call it, dial face in, they're not the same between the two units. I thought they were, and I just threw them in the common bucket. And I threaded this first one in, and it went in fine and snugged up. And I went to put this one in, and it just spun. And I said, oh crap, the threads are stripped out. And I grabbed another screw, and it just happened to be this guy's mate, and it just kept spinning. And I looked around in the tin, and I found the third screw, which was the mate for this one, and threaded it in, and it snugged right up. They're a different thread. So at some point in time they changed the thread or the thread pitch or size, or I don't know if one's metric and one's inch, but whatever it is, they are different, so just be advised. Now that I've got them in there, I'm noticing that everything's a little bit tilted, but when I was snugging up the screws on the meter movement, there was a fair amount of movement or slop in the holes. So I think if I just back these off a little bit, I can swing everything over and line it up. So I'm just loosening up the two nuts that hold the movement itself into the case. Let's see if we can oh yeah, that slid right over. Good. And I'm registering it on the two little flats down here. Okay, so I'm going to snug up the screws again, or the nuts. Maybe that's something that should be done last. Something else I've just learned, having never done this before. But, make sure nothing's moved. Nothing has. I'll snug up the other one. And it's a little hard because you keep bumping in against the side of the well and it wants to move it, but no, that looks pretty good. Everything's nice and squared up now. The only difference I'm seeing is I'm going to have to move the stop because the stop on this scale is a little bit further down. Not a big deal. Oh, too far. Too much. Move it back. Just the magnet on the meter is getting me. Okay, that's off. All right. We've got it. The balance on this meter isn't perfect. Maybe I want the stop down just a little bit more. There. Okay. Beautiful. Keep our fingers crossed. Well, I know this movement's good, so it came out of a working meter. I think that's going to look just fine. I'll put the studs back in, and I believe these are all the same length. I never took them out of the other face, so these should be fine. They do have a little square boss on them that fits into a molded, I guess, I don't know if that's, there's a little square molded into the meter face that they nest into. So let me get these in snugged up and we'll bring you back for the test. Alright, I hope you can, hope there's enough light in here to see black on black. The resistor's out. I've got the back-to-back diodes installed. I know these two diodes in the rectifier are okay. I tested those. They should be alright. I think this thing got blown up on, probably had it on the amps setting and tried to measure voltage is my guess. I haven't looked at what resistor's blown. But DC volts, let's see if things are working here. Let's start out with a simple one. DC volts and 1.5 battery on the 3 volt scale. Fingers crossed. Look at that. Ta-da! Okay, we're well on our way. Now my zero. Oh, geez, I forgot to line that up. That was a stupid mistake. I couldn't have gotten lucky enough. Oh, maybe I did. I got lucky and it went right in. Whew, what do you know about that? Heh, can't lose them all. Okay, there's a, yeah, exactly 1.5 volts on a 3 volt scale. That's a good indication. That means that range is working. How about the 12 volt range? Sure enough, 60 volt range. Sure enough, okay. Now I have to figure out what resistor it is that's blown up. And there's something cobbed in there. But I'm assuming that's a, well, I don't know. I don't know. That resistor definitely looks hosed. And there is a big skid mark there, so something blew up right here. But the meter movement's back. Let me make some resistance checks against the schematic, you know, resistance checks on this guy here against the schematic for this. And we'll get back to you. That's going to take a while, and I'm not going to eat up half an hour of your time with me ohming out resistors, but I'm just going to go around. There's a layout in here, tells you exactly what resistor is where on the switch. I know it's in here somewhere. Come on, come on. I've seen you. There we go. There's the layout. Tells you what resistor is in every pocket And I just got to look it up and check it against the list here and make sure all the resistors are correct. And then I'll probably change out this 0.1 microfarad. Of course, I never use the VU scale, but we'll change it out just for completeness. C2 looks like this is an orange drop, so this has been changed at some point in time, but they never bothered with the VU scale one. Let me get the resistors checked. We'll be back. Okay, ohms function's working, AC volts is working, DC volts is working. Now we have to see if we can get the VTVM going. There was one issue with this meter movement, and it was there before I swapped it over, and that was when you laid the meter down on its back, it would shift about 4/10, or 2 divisions. It'd be about 4/10 of a volt on this scale, I guess. Depends on what scale you're on. It was about 2 divisions it would shift. The meter movement was out of balance, so while I had it opened up, I went ahead and balanced the meter movement, so now any angle it's at, the needle returns to 0 correctly. Now I just put static electricity on it. Yeah, I knew that was going to happen after I cleaned it. I'll have to rub it down with a dryer sheet. In fact, I should get one right now and just be done with it. These meters are extremely sensitive to static. Once you remove that coating off the, I'll probably have to, nope, it went upscale that time. Come on. There, now it's back to 0. Once you've removed that anti-static coating, you've got to be aware of the fact that they'll go up and down scale, sometimes just moving your hand past them. This had two 22.5 volt batteries, as I said earlier. They were nestled in here. Now there's a guy out there who makes a circuit board, 2 printed circuit boards actually, that will fit in here and hold, I think it's 30, I think it's 15 and 15, yeah, be 15, yeah, 15 and be 22.5, 15 times 1.5. 2 printed circuit boards that fit in here and hold 30 quad A, not double A, not triple A, quad A, 4A cells, and gives you 22.5 because it's split up between 2 of these. And I looked into that, and it would be about $35 worth of batteries. Then I'd have to buy the circuit boards, and then I'd have to go to Mauser and buy all the battery clips to solder to the circuit boards. It ends up being like $75 when all is said and done. I have 9 volt batteries. I buy them in bulk, and I've got little snap-on connectors. 3 9s is 27. That's a little higher than the 22.5, but I'm hoping that there's enough range on the 0 knob to 0 the meter with 27 volts versus 22.5. Now this doesn't seem to this isn't a bridge circuit as such. It's a different setup on the VTVM. I believe it's just a straightforward amplifier. I'd have to trace this schematic out, but there's only 1 tube, so I believe they're just using it as a DC amplifier with a high impedance grid input. But I should hopefully be able to balance out, there should be enough range, I'm hoping, on the 0 knob to 0 the meter out. So what I'm going to do now, actually, the cover will fit on here, the back cover will fit right over the top of these once everything's in place. And this is a much cheaper solution than buying, a box of, I think you can get them in boxes of 50 of the quad A cells. And the 2 circuit boards and all the battery clips to go on it, so you can get 50, the 2 boards fit in here with 15 cells on each one. I'm going to try this. I'm going to set up, I'm going to wire this thing up, and we'll see what happens. I'm just going to keep my fingers crossed and hope I can get away with this. Okay, early into this, I said that this VTVM wasn't using an actual bridge. It's using what I would probably call a pseudo bridge. This is your standard VTVM circuit. You've got a 6AL5 rectifier for rectifying AC to DC, and then you have your bridge circuit here for your meter. Now this is virtually the same circuit that's in every VTVM ever made. There'll be minor differences here and there, but this basically is every VTVM, whether it's an ICO, a Heathkit, RCA Senior, Volt Ohmist, whatever. They're all basically this same circuit. And this is distilled down to the simplest components. You've got a dual triode, the meters across the cathodes. You've got two fixed resistors here, two variable resistors here, one of them fixed to ground so that it doesn't change. This is just a balancing circuit to make up for any difference in emission between the two tubes. When we introduce our DC voltage here, it changes the conduction of this tube, unbalances this cathode. You get a difference in voltage between these 2 points, and the meter reads. When everything's in balance, these 2 points would be the same voltage and you get zero current flow through the meter. But when you unbalance it by introducing a voltage on this grid, the two cathode voltages differ and the meter reflects that difference, and that's your reading. I've left out all the stuff that, all the balancing and calibration stuff. This is the basic circuit. This is the VTVM VOM. Isn't that a fun little schematic? Stare at that for a couple minutes and give yourself a headache. You don't have to. I've done all the hard, heavy lifting for you. This is what it distills down to. We've got our meter. We've got two 22.5 volt batteries, and we're picking off the center here, the center tap of the batteries for the one side of the meter. We have a 1R5 vacuum tube, and we have our zeroing control. When everything's set up and working correctly, you've got two voltages here. Two voltages here are adjusted by this several compensating resistors. I've drawn one. You get a balance between this side and this side, and zero current flow because the voltage ends up being the same at both of these center points. When you introduce a signal to this grid, this tube starts conducting, throws the balance off between these 2 points, and you get a meter reading. The accuracy of this and the calibration of this is not going to hold for a long time, because as these batteries draw down, one's going to draw down faster than the other. So it's not really a perfect bridge circuit. It's kind of a pseudo bridge, but this is how they're accomplishing it with a single 1R5 tube, triode tube. What else is there to say about this? Oh, I am comfortable. I think I'm going to be fine using 27 volts and 27 volts, because as long as these two voltages are the same, I should be able to balance this circuit with no problem and use three 9-volt batteries and three 9-volt batteries rather than spending close to $100 to build something here to provide 22.5. We'll find out, but I think I'm going to be fine with 27 and 27. It should balance out, and I should be able to use the meter. What this is going to do, this is going to affect the times 100K ohms setting, because it's going to be using one of these batteries for the 1 times 100K ohm. And your standard 630, there's a 30 volt battery, this guy right here. This is what's used in the 610 for the ohms circuit. I think they went with 22.5 volt batteries because these have a lot more capacity. And with an ohm meter, you're going to go in, make a measurement, and be done. This might be on for a period of time, drawing current from these batteries. 2 of these 30-volt batteries wouldn't last very long. But these 975s, or XX15, or whatever number you want to assign to them, these are XX15, I think they cross-reference to that. But at any rate, these aren't made anymore. I could have put 2 of these in there, but the 6 9-volts ought to give me a lot of long life, a long time of operation. I'll be changing the A battery fairly frequently because it's used for the ohm meter, the lower 3 ranges on the ohm meter, and when you flip it to VTVM, it energizes the filament in the 1R5. What else? There was something else on my mind that I wanted to bring up. I think it leaked right out. I was talking about the batteries, talking about the... I don't know. It'll come to me and I'll stick it in later in the video, I guess. But I should be fine. I think this is going to work out just fine using the 3 9-volters. So I'm going to wire them up and we'll see if I'm hero or zero. And I remember what it is now. When you turn on a VTVM, you've probably all seen the characteristic, the needles swing up slowly and then swing back down as the tubes warm up. It's because as they're warming up, there's an imbalance in the emission between these two, but it's small, so the needle is usually pretty gently goes up and down. They warn you on this meter, there's 2 positions on the switch here. Oh, upside down. 2 positions here. Oh, note, these are higher than the meter face, so if you lay this down on its face, it doesn't scratch the face. It sits on these 4 points. Anyway, this switch, here's your VOM, volt-ohm milliamp meter side. It has a center position. That center position turns on the filament of the vacuum tube, and then that applies the B+ to the vacuum tube, and they tell you, slide this to the center position, give it 3 or 4 or 5 seconds to warm up, then switch it to the VTVM position. Otherwise the needle is going to slam to one end. And the reason being, before the tube turns on or warms up and starts carrying current and pulling the voltage down here, you're going to have a huge imbalance between this side and this side. You're going to have all the voltage here from this battery, and it's going to slam that needle to one side. So you want to turn on the vacuum tube heater first, so that when you flip on the B+, not all the switching circuitry has been eliminated from this, of course, for the simplicity. But when you turn on the B+, you want this tube ready to have emission so that the resistance here is balanced with the voltages here, and you don't end up whacking the meter on one end. So you have to remember to turn it to a mid position. Alrighty, that's that. Alright, we have our 6 9-volt batteries wired in series. The positive going here, center tap here to the center tap lead, minus over here to the minus. Fingers crossed. Yeah, let's just see what happens when we turn it on. Go to the center position. Yeah. I'll give it 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000. Okay. Slam, slam. Whoop. There's my 0 adjust, and I can adjust it to 0. Look at that. What did I do with the VTVM leads? In there. Oh, oh, oh. Man down. Triplett. Yeah, it's drifting down. Probably will continue to drift for a while until the tube warms up, and then it'll continue to drift as the batteries deplete. But let's see what happens here. First time I've had these out of the package. Probably ought to back up a little bit, get everything in frame better. Nice feeling wire, feels like a silicon wire. Probably should have taken these out of the package sooner and looked at them, but When they came in, I just set them on the bench. Now, you got some good Velcro there. They wrapped up in. Hey, okay. Common. VTVM. Some really good banana jacks there. Okay, let me, what range are we on? DC volts, 3 volts. Doesn't measure anything on my tongue. Where, oh, I need a battery. Oh, 30 volts. Here's a 30 volt battery. Let's go up to 60 volts. Which end of this thing is positive? That's the positive end. Okay. Let's see what we got. Well, I got it on the right setting. DC milliamperes. DC volts, 60 volts.
2 hours later.
Wow, am I feeling red in the face? Talk about stupid. I'm sitting here studying this schematic over and over, and I'm staring at the thing, and I see DC volts, amps, milliamperes, VTVM, ohms, and AC volts. And I go, wait, what? There's a separate range of voltage for the VTVM. And I go back and I look at the scale. Now, this says DC milliamperes, and there's an arc that seems to continue down this way. But it goes 1200, 120, 12, 1.2, 60, and then starts over with 120, 36, and 1.2. This is the VTVM voltage ranges. You have a 1.2 volt full scale, 6 volt full scale, 30, and 120 volt full scale on the VTM range. Now, you would never have to go any higher than that high impedance in most cases. Now, that was it Emerson that we had on the bench would be an exception. I would like to have like a 300 or something volt scale for the VTVM, because that 1.2 with the extremely high impedance. But these are the ranges for VTVM, and I'm on the 6 volt range now, and set my needle to 0. It sure likes to drift around a little bit. 1.5 volt battery, a fresh one, and 1.5 volts, because this is 2, that would be 3, 4, 6 volt scale, yeah, 6, so 1.5 volts right on this center range right here, the 60, or this 60, 1.5 volts. Working fine. And I'll go down here in the 30 volt scale, and you can see the needle comes up range. So it's working. It's 100% fixed. I just didn't know how to operate it. Operator headspace. Unbelievable. I spent about a half an hour sitting here perusing the schematic, trying to figure out what was wrong, thinking all the time that this range down here was part of the DC milliampere scale, until I took a really close look and realized the numbers repeated here, and I said, wait a minute. And the second part of the puzzle came clear when I was trying to figure out the switching contacts, and I saw DC volts, amps, milliamps, VTVM, ohms, and AC volts. I said, there's a separate range on the range switch. That's why I didn't have any input to the grid. This thing's fine. The meter replacement, the back-to-back diodes, putting some batteries in it, changed out a blown resistor, and it's back in business. We now have a portable VTVM/VOM that we can carry around with us. Now I'm going to get on with cleaning things up. We got to clean up all the dirt and all the numbers here, and we have to polish up the case, and then we have to take care of the leather case that it all came in. But my goodness, what a journey this has been. You've got to remember to set this thing back on volts, ohms, and amps. because if you forget it over here in the VTVM setting, an hour later you're not going to have any D-cell battery. The tube will suck it flat. This is only meant for intermittent service as a VTVM. This A battery, or this D-cell battery, what I'm calling it an A battery because it runs the filament, is also the low range ohms battery. Depending on where that VTVM switch is set, this battery is either used for ohms or for in fact, I should check the high ohms range on this. We're on volts ohms. Let's go 100K. And this is probably going to be a fair amount high on the scale because of the excess voltage. But that's okay. Let's see here. Yeah, it's going to go off scale, but I should be able to adjust that down. There it is. So there's the 100K. I'm using my 27 volts versus the 22.5 volts. So when I go to the lower 1K scale, it's going to be off, because they normally set these up when they switch ranges. They'll be very close. Now it'll be the same for the lower ranges because they all use, oops, I'm off. There's R times 1, R times 10, R times 1K. And normally if I had the 22.5 volt battery in there, when I went to 100K, it would still line up with the 0, but because I'm using 27 volts, I've got to readjust it. Small price to pay for the cheaper batteries. So that's the 100K range. This is the capacitor that came out of the output setting. This was supposed to block all DC and just allow AC through. And you can see it's basically a resistor. That's been replaced with a nice poly cap. That's used for measuring, sound level or audio level. But this cap that was in there is gonzo. Okay, I'm going to clean this up a little bit, and I'll get back to you when some of the work's done. And there you have it. We gave it the old clay bar and turtle wax routine, cleaned it up. Windex on a toothbrush, clean all the numbers up. Black boot polish. I had another strap, put a strap on this one. We gave this the kiwi black boot polish treatment, and boy, that cleaned up pretty nicely. That cleaned up real nice. This actually has a bail on the back of it. If you leave the meter strapped inside, you can put the meter on its tilt like so, which is kind of nice. And the standard 630. Which model of 630? This is the PLK version. Has the overload button. If you don't have, a word of warning, if you do one of these conversions with all the 9-volt batteries, you cannot route anything over the top. This one's got a clear back. You cannot route anything over the top of the D-cell. The wires all have to run down the side. That D-cell is pretty much up against the back of the case, and if you try to route any of those wires, even the thin ones, over the top, you take a chance on blowing the back of the case out when you snug the screws up. And I brought this one over here just so you can see inside how the thing is oriented. If yours doesn't have a 30-volt battery, I did a video where I showed how to take 3 9-volt batteries in series. 27 volts works just fine. And there's plenty of room in here to tuck the batteries away, down on the side, as long as you insulate the case of the battery so it doesn't short circuit on anything, because the 9-volt batteries have a metal outer case. And it's nice to have the 30-volt battery in there, because if you put this on the 100K range, this is the only range that uses the 30-volt battery. But you can take a capacitor on that range with the 30-volt battery, and you can actually check them for leakage. You can see how it's leaking. This is a bad waxy cap that came out of this one. Came out of the output jack. Does this even have the output? Yeah, it's down here. So you can actually check paper capacitors for leakage. The 30-volt battery dumps enough current through them that you can actually see the leakage in the capacitor. And it won't go down any lower than just about where it is right now. So there you have it. I'm done. I'm gonna call this one wrapped up and finished. It's kind of nice to have one that I can take with me that's got the VTVM function on it. If I have to go visit somebody, I can pull this thing out if I need a high impedance meter, and I've got my VTVM. Now that wheel is all the way wound up because I've been polishing the front of this thing. You just have to absolutely remember to switch this back when you're finished, or the batteries will go dead in about an hour. Probably my last video this year or this season, because I'll be heading out of here for Thailand in about a month, and I have a ton of stuff to do. I do my own work. I take the furnace oil burner apart, clean it before I go. The guy's coming for the septic tank pump out on Monday, and I gotta get that done. And once again, in the middle of conveying some very important information to you guys, the memory card filled up, and this camera gave me 0 warning. This camera makes me crazy. I'm sorry I ever bought this thing. But at any rate, we're going to wrap this one up. I won't try to recreate whatever it was I was talking about. We have it in its case, and if we flip its little veil back here, the camera or the meter will lay back and can be used in that position. Stays protected in its box. It's got a place over here for the leads to tuck into, and turn on our VTVM. I'm just pleased as punch that that thing is back in operation, and I can add it to my litany of test equipment here. We'll be off to Thailand. Again, I don't think I'll get another video out the door before I get back next April. So in the meanwhile, I'll try to, I might try to get a couple things out from Thailand. I don't have my normal video editor over there. I've only got the Microsoft Movie Maker, but if we come across some interesting place, I'll drop a short video on that from over there. In the meanwhile, stay well. Hope to see everybody again come springtime. And we'll wrap this up. Bye-bye.